conference. I really appreciate that you are visiting our talk today. I hope you are doing well and you are ready to learn new cool stuff about growing technology. Today, we will explain what Amazon Cognito is. We will show use cases of Amazon Cognito, how you can integrate it with other AWS services, why and where security issues may arise, what potential impact malicious actors can gain. And the coolest point, we will have a live demonstration of practical Cognito hacking. It should be fun, believe me, it should be fun. But before moving forward, let us introduce ourselves. My name is Pavel Shabarkin. Nice to meet you. I'm 22 years old. I'm a young specialist in cybersecurity field. If to describe myself shortly, I really love adventures and discovering how the things are working in the world. One of my hobbies is track and field. And I do running every day. I like to push and extend my limits. The same approaches I'm using in cybersecurity field. But I'm not alone today. I'm with my dear friend, with a man I'm doing researches and working side by side every day. Maksym Vatsyk.
Hey guys, thanks Pasha for the awesome intro. So my name is Max, I'm 19 years old. I work together with Pavel as cloud and web penetration tester at Octal Security. And hacking has not only quickly become one of my greatest hobbies, but also a sort of a lifestyle, as I learned it from the wonderful members of our local community. And what truly amazes me in hacking is the way that it introduces new challenges every day for you to master your skills and knowledge. And I'm simply thrilled by the impact that we can induce on the everyday people's life by simply writing a couple lines of code. And as the years pass, I can now proudly say, damn, I love my job. So before we move on to the main topic of our AWS Cognito talk, we want also to give a huge kudos to all the awesome people who had helped us along the way, them being Katya, Bogdan, and Sasha. Thank you guys. Without you, we wouldn't make it this far. So let's now talk about the AWS Cognito. Lots of developers commonly struggle with implementing authentication authorization according to best security practices. And we, as a security people, often find some critical vulnerabilities in this logic. And so, with the advance of cloud technology, AWS decided to encapsulate this functionality in the form of a service, AWS Cognito, which can be flexibly tuned and provides a top-notch security. So, Cognito provides the ability to sign up and sign in users through either the third-party identity providers or by using a built-in one, by the means of all common authentication protocols. It also provides you a way to authorize your user directly to your AWS backend by issuing temporary credentials and managing the permissions. And so, as the Cognito provides a way for the users to communicate with the backend without any middleware in place, it indirectly enforces the serverless infrastructure in a very convenient way for the developers. There are two main components of AWS Cognito, them being user pools and identity pools. User pools are responsible for the authentication. They provide the user directory in which you can define the user attributes such as username, email, phone, etc. They also allow you to customize the authentication process and MFA settings. And so by using user pools, your user can authenticate themselves to your web or mobile application either through the external identity providers or through the Amazon Cognito directly. Identity pool take care of managing access to your AWS backend by issuing temporary AWS credentials based on their inherited permissions from the user pools. And before we dive deep into the exploitation, let's discover these services in detail.
When you are thinking about user pool, you should imagine some sort of service what manages all your users and is responsible for authentication and security of this user. So developers don't need to reinvent anything anymore. User pool supports all major authentication protocols, so as well as allows to create you a custom one. User pool offers easy and flexible user management in Amazon console. You just need properly implement configuration for these users and integrate user pool into your application. To get a better understanding how this component works, let's discover login flows and use cases. There is two types of login flows, client-side and server-side. What happened when user authenticates to user pool API? User provides credentials, and then what? User pool responses with bundle of JSON Web Tokens. Using them, you can subsequently directly communicate with Amazon Web Services. The main idea of Cognito to follow serverless approach. That's why the client-side flow is a default one. But what if, being a developer, I don't want to follow serverless approach? Okay, Cognito has server-side authentication flow. It's when user provides credentials to your application backend, which authenticates into user pool API, and user pool responses with JSON Web Tokens, and then application backend subsequently communicate with Amazon Web Services on user behalf. But also, with the help of Lambda, Cognito gives ability to redefine some default processes of user authentication. We know about two default use cases of standalone user pool implementation. There is an example when user can authenticate directly to backend resources having only user pool tokens. So the major point here that in this case, developer need to implement some sort of validation on your backend resources having only user pool tokens. At the first step, user authenticates user pool API, user pool responses with bundle of JSON tokens, and then user trying to access resources on your backend. But we have another one, easier in implementation. The validation of user pool tokens is performed by Amazon API Gateway. So developer doesn't need to reinvent anything again. So just configure and use it. At the first step, user authenticates to user pool API responses with bundle of JSON Web Tokens, and then it tries to authenticate and get access to backend AWS services. There is an example of user pool API response. When users successfully authenticate to your system, user pool responses with a bundle of JSON Web Tokens, access, ID, and refresh token. Access token is used to grant your users access to your own server-side resources or Amazon API Gateway. So there is a decoded payload part of access token. You may notice we can enumerate here Cognito groups, which user is a member of. Next is ID token. ID token is used to verify your identity. It contains claims such as name, email, phone number. It also can be used as an access token. But again, here you can enumerate not only Cognito groups, but also Cognito roles. During practice activities, we will demonstrate why enumeration is important at this point. Now, Maksym, is your turn.
So, identity pool being second major component of AWS Cognito service, as we had already said, is responsible for managing the permissions, the user access to your AWS backend resources by issuing them temporary AWS credentials based on the inherited permissions from the user pool. And so, upon the request from the user, identity pool verifies the credentials provided and identifies the possible IAM roles that can be assumed by the user. If everything is correct, the user issues temporary AWS credentials having an expiration time and a limited use scope to the user, assuming the requested role. And after that, your users can use these credentials to communicate with your services. So let's discover the login flows and the use cases of identity pool. So the first one involves the implementation of user pool and identity pool together. So at first, your user authenticates themselves to the user pool and obtain the bundle of JWT tokens. Then they would exchange the ID token from the user pool for the temporary AWS credentials from the identity pool. And after they had obtained these credentials, they are free to communicate with your backend resources such as Lambdas, S3 services, RDS, or whatever you had set up in your serverless application. Identity pools can also be used as a standalone service. To do this, you would have to set up the login flow using the third-party identity provider. And after the login flow is completed, your users have to specify the login proofs in the request to the identity pool in order for it to issue the temporary AWS credentials. And of course, after the flow completion, users obtain the temporary AWS credentials, which they would use to access your backend resources. So here's the sample response from the Cognito Identity Pool service looks like, which contains the temporary AWS credentials. As you can see, they are pretty much in their standard formats, except from them having an expiration time and the session token field. There are also bonds with the identity ID. Identity ID is simply a unique user identifier in the identity pool, which is responsible for identifying a user when they use these temporary credentials. So that's pretty much all that you need to know about these components for us to move on to the presentation, to the practical part of the presentation. But we also want to make a footnote on AWS shared responsibility model.
Hosting application infrastructure in cloud, especially in AWS, you should understand the shared responsibility model. AWS is responsible for protecting the infrastructure that runs all the services offered by AWS Cloud. This infrastructure is composed of hardware, software, networking, and facilities that run AWS Cloud services. Customer is responsible for client-side, server-side encryption, for network and firewall configuration, for access control and application configuration. Same thing applies to Amazon Cognito. If the developers poorly configure user policies, malicious actors may compromise your infrastructure. Let's see how it may happen. We prepared DAM website for you. We want to show 4 attack vectors, and you can follow this link and try it by yourself after our talk. Please switch to my screen recording. I will go and explain. Awesome. So it's how looks like octopusstorage.cloud. Octopus Storage is a free file storage platform. We have team developed this website. It's Maksym, Pavel, and Alexander. Let's register a user. We will go to sign up. Let's register user called temp user. We will specify temp user 3 password. Use password, please. Okay. We will use our temporary email address. When we're trying to register an account or log into application, we're communicating with user pool API. So I provided username and password and email, and confirmation code was sent by user pool. So it handles everything by user pool. I'm waiting for confirmation code. I can see here my confirmation code. I successfully registered a user. So let's try and log in. We have temporary user. Success. Okay. So once it's Octopus Storage, it's file storage platform. So probably this website has functionality for sharing files, for hosting files, and in the cloud, right? And what's actually happened when we log into our application, who is main for processing this information. Let's go to Amazon Cognito. It's how AWS console looks like. We choose Amazon Cognito service, and we're going to manage user pools. We created Octopus Storage user pool and integrated with our website. So let's go to Octopus Storage. We can see here pool ID, pool IRN. We will go to users. Now you can see that 4 users are in the system. We just created a temporary user. We can see it's enabled, confirmed, and email address. But when we're talking about Cognito, we mentioned that it's followed serverless approach. And okay, we're communicating with other AWS services directly. So probably we need to have some permissions, because I didn't like if any user could access my resources, right? So to check permissions, we can go to groups. We see here that every user is assigned to some group. For example, storage users. We go and we can see here role IRN, Cognito Octopus Storage with role. To check what role, what this role permissions has, we can go to IAM. We need to choose roles. Let's find this Octopus Storage with role. And we can see here that 2 policies are attached to this role: S3 good practice and S3 bad practice. Let's tap on bad practice. Okay, here we can see that 4 actions are allowed for every authenticated user: put object, get object, list bucket, and delete object. And all these actions are applied to resource called Octopus Storage Files bad practice. So it's a S3 bucket called like this. And okay, I'm thinking that every user can upload file, get file, list files, and delete files. It seems like normal functionality, right? If we go back to our website and we will go to files, I'm a temporary user right now, and I can see that I have no files here. So let's upload it. We'll call AWS enumerator.jpg. We will browse and upload. Yeah. Before uploading file, let's turn on the network proxy group suite, and we will intercept traffic and see what actually happens. Tap in upload. Loading. When we authenticate into a website, we communicating with user pool API. But when we want to access any AWS service to communicate, we need to exchange our ID tokens for temporary AWS credentials. And the first request, when we authenticated, user pool responses with bundle of JSON web tokens. And then having ID token, we can exchange it for temporary AWS credentials. You can see them here. So let's put it in AWS command line interface and see what we can do with them. I grabbed access key ID, now secret key ID. The region is US East 2 and session token. Now I'm copying all these parameters, and I want to copy them to global variables. Now to check who we are in the cloud, we can do AWS STS get caller identity. It's like who am I in the cloud. So we can see that IRN role is assigned to us is Cognito Octopus Storage Auth role, what we saw in the AWS console previously, right? Here. Okay, there is a question. If I have these permissions, put, get, list, and delete, to the resource called Octopus Storage Files and Best Practice, can I access resources of other users? Let's figure out. What I'm planning to do, I'm planning to access S3 buckets. Let's do listing. We can see here that we have access denied. But why? Because we're trying to get all buckets on this infrastructure. But we here have access only to this bucket. So let's try to access this one. We'll specify it, ls, s3, and name. And what we can see here is we have default user A and default user B folders already created. Why? Because these users were registered before and probably may have some files there. But before showing the exploitation, let's go and upload some files to our storage. Signature.maps. Let's upload it again. JPEG. It's intended functionality of this site. Okay, so we can access folders of other users, right? Let's go and list what files these users may have. You can see we need to specify /. And we can see the default user A has file JPEG, probably some sort of private photo. I don't intend to have an access there, but what I can do here, I can probably steal this file. My computer. Download. So it's weird. Let's do ls, and we can see here that I have this file. Why it happened? Because developer or DevOps created policies that every authenticated user can access this resource from the root. So every user can access this S3 bucket. Please, let's go to our presentation. And discover what is bad practice for configuration for services. So there is an example what is not to be applied in your infrastructure when you creating actions for every authenticated user, for every Cognito user, you allowing them to access entire bucket or entire resource. What would be a good practice is that every Cognito user has some kind of identifier in system, and you applied policies that user can access only portions of a resource by their identifier. So in this case, Cognito user could access only resources portion for them. We also have prepared Another one, attack vector, shared user pool issue. Let's go back to my computer. And see what we can do with our website. Let's go back to Cognito. Okay, let's log out. For example, we are a public company and Octopus Storage may have some administrators to manage the application, right? We did some reconnaissance and we explored that Octopus Storage.cloud may have admin subdomain. Let's go to subdomain, and we can see here that Octopus Storage admin is publicly available, and we can authenticate to it. Yeah. What would be the weird scene here? That normal user can authenticate here, but is it actually can? So let's try. We created temporary user, right? And we can just try to log in. And we can access admin panel. Why it happened? As you can see here, we have Cognito admin. If to go back to Amazon Cognito, we go to manage user pools. We go to Octopus Storage, to users. And we see that Cognito admin, default user A and default user B and temporary user are in the same user pool. So if you remember, I mentioned that user pool can have standalone implementation. When having access or ID token, you can access your server-side resources directly. And this is the case when Cognito admin group being in the same user pool with other users was access to our backend resources. And there is a point that you really need to divide your admin users and customer users. So let's back to our presentation. The advice here to divide your user pool. So if you need to have some admin panel, you need to have admin user pool. And if you have customer application, you need to have another one user pool. So divide your user pools to avoid the confusion of and not to allow average users to access your admin resources. Thank you. Max, your turn.
Okay, so our next attack vector is an all times classics. It's injections through user data. So lots of people tend to think that if they use some kinds of a cloud service, which AWS Cognito obviously being one of them, they would have their input sanitized and presented a secure output on the backend. However, this is clearly not the case. AWS Cognito does not sanitize user data. However, we want to emphasize once more that the issue described here has nothing to do with AWS Cognito service itself. So the service handles the data okay. Instead, this is a developer code which was written by us, and it handles the Cognito data incorrectly and allows the following attacks. So AWS Cognito only performs some kinds of basic checks, for example, for an input field to match the email or phone number format. And if you do want to sanitize user data, you would have to set up a custom Lambda trigger in order to perform this functionality by yourself. We're going to show you the example injection in the username field. Username field is the default main field in the Cognito user pool as it is created. So users use it to log in and sign up to your application. And in fact, it has two main constraints, one of them being the matching this long and ugly regular expression, which basically means there should be no white spaces in the username. And the second one is that the username should be less than 128 characters. And with these constraints in mind, we can totally bypass them and construct some pretty complicated payloads. There are three possible injection targets in the application infrastructure. One of them being obviously the application front end. So an attacker could inject the malicious JavaScript into the username field, and it would get rendered in the victim's browsers and be run. The second target is the custom Lambda triggers, which are set up by the developers. And if they handle the data in an unsafe way, we are able to compromise the execution flow and actually attain a foothold in the AWS infrastructure. And we do have this attack vector set up in our demo application, but we will leave it for you to try it out. And the third one, the third target is obviously some common backend service, such as database or application service. So with that out of the way, let's move on to my presentation, my computer. So as Pasha has already told you, we have the admin panel, admin.octopus storage.cloud. And let's exploit the issue with the shared pool. Pasha has already told us before, and log into the admin panel using the default user B credentials. So as you can see, we are presented with the list of the application users present. And let me tell you more about the admin panel. So it is written on a Python Flask framework, and actually utilizing the server-side login flow. And to utilize the server-side login flow, your application must be authenticated to the AWS infrastructure using developer credentials. And these developer credentials, of course, could have some privileged access over the Cognito service. So if we are able to compromise the credentials, we would likely have the privileged access over the authentication, authorization functionality of the application. So we have constructed this admin panel to be vulnerable to the server-side template injection in the username field. And yeah, let's go and try it out. Let us sign up a user with a malicious payload in the username. And the username would be request.globals.builtins.import OS environment. What this username does, it's just basically utilizing the server-side template injection and to construct the custom toolchain of Python objects to import the OS module and display all the environment variables present in the application, which our credentials are hopefully in. So let's sign up to the application. So let me provide the temporary email. Storage. Yes. And as I clicked sign up, you can see that the application didn't give us any errors. And so that means that basically the username is totally correct and should be accepted by the Cognito user pool. So let us finish the registration of the user. Oh, here it is. So we should now be registered and displayed in the admin panel. And if we refresh the page, we can actually see that our payload got triggered and we have compromised the AWS credentials, as well as the user pool client secrets and client ID. So using these credentials, you can actually advance further in the infrastructure, but we'll leave it for you to try it out. So this is the end of my demonstration. Let's get back to the presentation. Our main advice here would be never trust the data coming from the user, despite of its source, and sanitize your user inputs everywhere. And so we have come to our final attack vector, which is privilege escalations through IAM roles that can be assumed by the Cognito user. And there are basically two main sources of user privilege, sources of IAM roles that can be assumed by the user. One of them being obviously Cognito user pool groups to which a IAM role can be attached. And the second one is default IAM roles, which are created upon the identity pool setup. So they are basically the default ones and are assumed when the user either does not provide the specific role to be assumed, or to whether or not they are logged into the application. So as we had already told you, you can enumerate all the possible user pool IAM roles which are granted to you by looking into the payload part of your user pool ID token, and there would the ARNs of IAM roles be listed. But before we show you how to actually assume the role, let us quickly take a note on the Cognito pool and Cognito service and how it handles wildcards. So Cognito is one of the few services that actually makes a difference between temporary AWS credentials issued by it and permanent developer credentials in order to avoid disaster. And what it does, it just basically scopes all the majority of sensitive actions to be only available from the permanent developer credentials. However, there are still some privileged actions that can be used via the temporary AWS credentials. And so these two actions are a perfect example for this. So admin reset user password is a privileged access, privileged action that can be only used by the developers. However, in the contrary, admin set user passwords is totally available from the temporary AWS credentials. And they do the same action in the application. So they serve the same purpose. But we can actually use this admin set user password from the temporary AWS credentials. So in order to assume a role, you would have to enumerate all the role ARNs, either through looking into the payload part of ID token or by searching them through the application codes. And after this, you should include the custom role ARN and specify the target role ARN as the value of this field in order in the request to the identity pool in order to issue these credentials. So let us switch to our final demonstration. So let us quickly get back to our client application and log in as a default user B. As you can see, my traffic is being proxied to the burp suite, and we actually are able to capture the request from the Cognito user pool, and here are the tokens, as you can see, the access token, ID token, and refresh token. And let's just copy and paste our ID token to see what's actually contained within. So as you can see, there are two role errands, one of them being Cognito Octopus Storage Auth role, which is actually used in the application to communicate with the S3 services. And the second one is AWS Cognito Best Practice List Users role, which is actually used to list the users in order to for sharing functionality to work. So let's intercept some requests to the identity pool and try to assume the AWS Cognito Best Practice List Users role. So as you can see, here's also our request to the identity pool, and you can see that no custom role errands are issued, and the identity pool responses with the credentials to the default role. So let us quickly change that and add our custom role errand field and specify the errand of the roles we want to use. Let us make this a valid JSON and send the request. So as you can see, the identity pool responses us with the credentials, and let's copy them and see who are we now. Let's get in console and do this. And let's try AWS STS get caller identity action. And wait a minute, it should load fine. And yeah, we are actually now under AWS Cognito Best Practice List Users role and have these permissions. So what this role was created for is to list users in the application, and it does it by calling the AWS Cognito IDP list users action. And this action requires a mandatory attribute, a user pool ID. And we can actually extract it from the logins part of our request. So this is a full ID of the user pool. And this is a short form of it. So let's copy and paste here. And as you can see, we are presented of the users list in the application. And so why don't we try out the admin set user password action, which should be accessible from the temporary AWS credentials, and see whether or not we have these permissions, these excessive permissions. So let us specify the victim. It would be Cognito admin. And let's add permanent flag to make this password permanent, because if we omit it, the Cognito will assume that this is a one-time password that we would have to change it when we log into the application. And let's specify the password. So as you can see, the action returned no output. That means that it should have gone smoothly, and we are now able to log in to the Cognito admin user using new password. So let us type in the username and use a new password. And as you can see, we have indeed compromised the AWS Cognito admin account by exploiting some of the excessive privileges that are available to us. So let's get back to our presentation. Our advice here is just to audit all the user policies that can be assumed by your Cognito users and remove excessive rights, both on the standard AWS services as well as on the Cognito, in order to prevent this from happening. So this is pretty much the end of our talk, and we would like to emphasize once more that AWS Cognito is a wonderful service which can be tailored to what you need in a very convenient way for the developers. But as it happens to the best of us, Cognito can be also misconfigured and lead to some of the worst possible vulnerabilities, including the complete or partial compromise of your AWS infrastructure by utilizing some of the common attack vectors. So thank you guys for the attention. And if you have any questions, we would love to answer them.